So today we are going to use our knowledge of quadratics and factoring and solving with quadratic formula and complete the square and all those things to solve application problems. Just 3 of them to do. So there's a piece of machinery that produces rectangular sheets of metal such that the length is 3 times the width. Equal size squares measuring 5 inches on one side can be cut from the corners, resulting in a metal that can be shaped into a box. So this is the sheet that they make. They cut out these blue corners right here, and then it gets bent and made into this box. The specifications call that the box must have a volume of 1,435 cubic inches. Remember, if you have a unit cubed, a unit to the 3rd power, that equals the volume. If you have a unit squared, that's the area. So it says it wants me to find the original dimensions. So volume equals length times width times height. So let's plug that in and let's make some math happen. So my volume is going to equal my length, the 3x minus 10 right here, times my width, the x minus 10, times my height, which is the 5 over here. And that volume that I have has to equal 1,435, 3x minus 10, x minus 10, and then multiplied by a 5. I'm a firm believer in making things reduce before I multiply them out and make them big and ugly. So what I did is I multiplied this side by a 5 and this side by a 5. If you do it to one side, you have to do it to the other. Those 5s are going to cancel out, and 1,435 divided by 5, you can use a calculator, is 287 equals my 3x minus 10, my x minus 10, and I'm going to FOIL this out. So I get 287 equals 3x times x is 3x squared. 3x times negative 10 is negative 30x. Negative 10 times x is negative 10x. And then negative 10 times 10 is positive 100. Quadratics need to equal 0 before I can do magic math with them if I'm going to factor or do quadratic formula. So I'm going to subtract the 287 over from both sides, and I get 0 equals 3x squared minus 30, not 30x, I'm going to combine like terms. These two can get combined together to make a minus 40x, and then 100 minus 287 is negative or minus 187. So now we've gotten to the point where we can factor or use quadratic formula. So we have some choices. I'm going to try to factor. If it doesn't factor, we can go back and do quadratic formula. But to factor this, you have to do 3 times 187, and that's going to, or negative 187, it's going to get me negative 561. So over here, 561. I'm going to just guess some factors. We can try 17 and 33. And because the 40 is negative, the bigger one here would have to be negative. That's not going to work. That's not going to add up back to my negative 40. So I think I've gone too far. I need to work my way backwards. 10 doesn't work. Let's try 11. So if you do 561 divided by 11, you get 51. That's going to work. I make the 51 negative because this term is negative, so the bigger one's negative. And if I add these two together, I get my negative 40. And we know that if I multiply them together, I get back to my negative 561. So 0 equals 3x squared minus 51x plus 11x minus 187. This is that factor by grouping thing. Again, I'm going to make a group, a yellow group, and a green group. In my yellow group, they both have a 3x in common, so I'm going to pull a 3x out. I'm left with an x. 51 divided by 3 is a 17, so minus 17. In my green group, they're both divisible by 11. X minus 187 divided by 11 is 17. And then you'll notice in both my yellow and green groups, I have this x plus 7, or x minus 17. So I have 0 equals x minus 17, 3x plus 11. So now when I solve this for 0, because the whole point of factoring is to use the zero product property, and now you can set each piece of this equal to 0. So 0 equals x minus 17, 0 equals 3x plus 11, x equals 17, and x is going to equal negative 11 thirds, minus 11 over and divide by 3. This is not the solution I want. Mathematically, that number works, negative 11 thirds. Remember, this x represents part of a side length, and I can't have a negative side length. So I'm only going to use the 17. So I'm going to go back up top, way back up top, so I can solve the problem. Because it wants my dimensions. So in my box, x is 17. So if I want to find the length was the 3x minus 10. X is 17, so 3 times 17 minus 10. That should get you 41 inches for the length. The width we called x minus 10. X was 17 minus 10, so I get 7 inches for the width. And the height had no variable in it. The height is just 5. So there's my answers, 5 inches. Let's try another problem. Hopefully from geometry and even 8th grade, you remember Pythagorean theorem, a squared plus b squared equals c squared. It's for a right triangle only. C squared, or c, is always the hypotenuse. And then A and B are always the two legs. So the next example says that I have a piece of property in the shape of a right triangle. The longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the length of the triangular lot. And they gave us a nice picture to help us out. So I'm going to call this A, B, C. So if I do a squared plus b squared has to equal c squared. A is called x, and then we square it, plus b is 2x plus 20, and then we square it, equals c is 2x plus 30, and then we square that. So before I put it all together, let's do each piece. So this piece is really 2x plus 20 times 2x plus 20, and we have to FOIL that. 4x squared plus 40x plus 40x plus 400, which is 4x squared plus 80x plus 400. And then this one I do the same thing. 2x plus 30 squared means 2x plus 30 times 2x plus 30. So when you FOIL, you should get 4x squared plus 60x plus 60x plus 900, which is 4x squared plus 120x plus 900. So let's put it all back together. I have x squared, don't forget my x squared that I had earlier, plus 4x squared plus 80x plus 400 equals, my green stuff, 4x squared plus 120x plus 900. I'm going to combine like terms, move everything to one side. The first thing I noticed right away, though, is if I subtract 4x squared from this side and 4x squared from this side, those cancel off. And so I'm going to move everything actually to the x squared. I'm going to minus the 120x minus the 900 minus the 120x minus the 900. I want it to equal 0 because I'm dealing with a quadratic. X squared, 80 minus 120 is negative 40x. 400 minus 900 is minus 500 equals 0. This should factor nice and easy. Two numbers that multiply to make 500 that add up to make 40 are going to be 50 and 10. The 500 is negative, so only one of my numbers needs to be negative. It's the 50 because negative 50 plus 10 makes negative 40. So this factors into x minus 50. X plus 10 equals 0. So x equals 50 and x equals negative 10. But a reminder, this side right here, it's an x. So plain old x means that this cannot be an answer, the negative 10, because I cannot have a negative length. So x is going to equal 50 meters. The question did, however, ask you to find the missing lengths. So let's do that. So here's my triangle. We know this side over here is 50 because it was just x. This side was 2 times 50 plus 20. This side is 2 times 50 plus 30. So my final lengths are 50 meters. That's one leg. The bottom leg is 120 meters. And the hypotenuse was 130 meters. Okay, last application problem. So first of all, this is a very important formula. It is projectile motion. The negative 16 is the force of gravity. It's in feet per second. And then V naught stands for my initial. Velocity. T is my time in seconds. And then S naught is my initial height. So if whatever object I'm launching or projecting is at an initial height of some distance, and that's what you plug in for S naught. And then S, my final answer, is my final height, my ending height. So it says that if a projectile is launched upward from the ground, so some keywords in here, from the ground means that S naught equaled 0, with an initial velocity of 100 feet per second. This is my V naught. Then it tells you the model. How nice, they gave you the model. First question is, after how many seconds will it be 50 feet above the ground? So I want my ending height to be 50. So 50 equals negative 16t squared plus 100t. Quadratics always equals 0, so 0 equals negative 16t squared plus 100t minus 50. I subtracted the 50 over. And honestly, you could try to factor this, but I'm pretty sure it's not going to factor, and we used lots of brain power to factor the first one, so let's just use the quadratic formula. Quadratic formula, in case you didn't remember, we usually say x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And in the quadratic, it's x, 0 equals ax squared plus bx plus c. The coefficients are the numbers. In our case, we don't have x's, we have t's. That's okay. So we're going to write t equals instead of x equals. This is my a, my b, my c. So the opposite of b is negative 100 plus and minus the square root of negative 100, parentheses matter, gotta square the whole thing, minus 4 times negative 16 times negative 50. all divided by 2 times negative 16. Okay, t equals negative 100 plus minus square root of 10,000 minus 3,200 all over negative 32. And then this equals negative 100 plus minus the square root of 6,800 over negative 32. I want to talk about just this piece for a second. 4 times 17 is 68, so 4 times 1,700 is 68, like that. And the square root of 4 is a 2. So I can rewrite this as negative 100 plus minus plus minus 2 square roots of 1,700 all over negative 32. And then this number, and this number all can get reduced by a 2. So that gets me negative 50 plus or minus square root of 1,700 all over negative 16, which you can type in the calculator, and honestly, you could have typed it in up here at this step. Just practice reducing, never hurt anyone. You should get t is approximately 0.55, comma, 5.70, and they're both seconds. So this happens twice, and if you think about it for a second, projectile motion. I launch something up in the air and it comes back down. So right away at 0.55 seconds, it's at this height of 50. And then 5.7 seconds later, back at that same height again. So I have 2 answers. Let's go do letter B. Letter B says, how long will it take for the projectile to return to the ground? If it's returning to the ground, then s equals 0. So 0 equals negative 16 t squared plus 100 t. It already equals 0, so factor out a t. They have a t in common. Negative 16 t plus 100. T equals 100, or negative 16 t plus 100 equals 0. This makes sense because when it starts, it's on the ground. But for this one, I do t equals, I minus the 100 over and divide by negative 16. And then you get 6.25 seconds. So it'll be back on the ground in 6.25 seconds.